This might look like a regular factory or power plant, but it's not. You won't see plumes of smoke coming out of here for one very good reason. The exact opposite is happening. These machines are a new type of infrastructure that sucks CO2 out of the air, and they could become one of our biggest weapons against climate change. But how do they work? Are they as important as we're being told? And could we be about to see them built everywhere? Is this really the tech that's going to save us from global warming? Or is it all a load of hot air? How to cut carbon emissions. It's an issue we're so used to hearing about that we've become experts without realising. We know that swapping fossil fuels for clean energy is key, and the good news is we're seeing more of this happening than ever before. The cost of wind and solar has fallen sharply, nuclear is getting popular again, and governments all over the world have launched big carbon cutting schemes. It all sounds very encouraging, but the reality is this: it's still not enough. Even with all the progress being made, some degree of global warming is kind of inevitable from all the carbon we've already pumped out and the greenhouse effect it creates. But what if there was a way to slow, stop, or even reverse the process by removing that carbon from the atmosphere? Is that even possible? Well, it's already being done all over our planet thanks to a process called carbon capture, utilization, and storage. It's often shortened to CCUS or just carbon capture. As the name suggests, it involves capturing CO2 either from a single source or straight out of the air and then storing it, usually underground, or finding another use for it, like making building materials. More on that in a minute. The multi-billion-dollar carbon capture industry is taking shape, but the future of many projects is still uncertain. Supply chain issues and rising construction costs are trickling down to some everyday citizens. But one startup is turning a different trillion-dollar industry on its head: the fine art markets, and it could actually help lessen some of the economy's impact on your personal savings. With Masterworks, almost anyone can invest in high-value contemporary art from legends like Picasso, Banksy and Monet at a fraction of the cost that people like Jeff Bezos and Bill Gates would pay to purchase. Their team has built a massive art database tracking records from auctions spanning decades. They purchase the art up front, store it for 3 to 10 years, and if the painting sells for a profit, you receive your share. In 8 of their 9 exits, Masterworks has delivered net returns to their investors of more than 13.9%. To keep up with demand, they're planning to open new offerings on a weekly basis. Nearly 600,000 people have signed up so far, so there's a waitlist. But tomorrow's build subscribers can get priority access at the link in the description. Now, let's get back to the video. The most common method of carbon capture is called point source capture, and it's actually been around since the 1970s. It usually involves filters, scrubbers, or other devices placed inside the emission source of an industrial facility which stops CO2 from being released. One example is in Norway, where Aker CarbonCapture and Norcem are equipping an old cement plant with the technology.
Basically, the emissions, rather than going through the flue stack, which is what's happening today, the emissions are routed through a vessel that has some solvent in it, and that solvent absorbs the CO2. From there, the solvent has to go get heated in a second kind of tower, and that's called a stripper. And what happens there is the CO2 is removed. And then the CO2 needs to be transported.
It then gets sent to wherever the CO2 is being stored or reused, usually via a pipeline, road or rail. There are now dozens of these facilities in commercial operation worldwide, and that number's growing. But what about that second category, taking it straight from the air? Surely that's going to make an even bigger difference. Well, potentially, yes. It's known as direct air capture, or DAC, and it works like this. Machines that look a bit like giant air conditioners use fans to draw air inside them where the CO2 is filtered out. Canada's Carbon Engineering does this using a series of chemicals, while others use special materials. That CO2 is then either treated or heated so it can be disposed of, while the clean air passes back out the other side. In the case of Climeworks, based in Switzerland, the CO2 is mixed with water and buried deep below ground where it mineralizes and can be stored for thousands of years. Not only do these machines deal with the emissions we've already produced, there are less limits on where they can be placed. They don't even need to be near a source of emissions, let alone inside one.
That is absolutely important as well. However, the concentrations of CO2 in the air are much lower than the concentrations at an industrial source. So the amount of CO2 you're going to capture for the amount of energy that's required is less.
Although the first commercial plants are now starting to emerge, like this one in Iceland, DAC technology as a whole is still in its infancy. But one advantage it does have is that it can tackle that huge backlog of CO2 we've built up over centuries, which is a lot, if we can build enough of it. The fact is, removing carbon from the air is not just going to be something that's nice to have. We're going to need to do it. To limit warming to 1.5 degrees Celsius by 2100, as set out in the Paris Agreement, some estimates say we have to remove billions of tons of CO2 every year by 2025. Up until now, we've only captured and stored around 300 million tons in total. So yeah, there's a long way to go. And while there are several point source facilities in operation and hundreds more in development, the numbers fall quite a way short of what's required.
By 2050, so I'm going out quite a bit, studies suggest we need to have stored over 100 gigatons. And basically, in order to get to that stage by 2050, we need over 1,000 CCS facilities of the typical average size. And today we have 30. We need more than the 150 that are in the pipeline. We need that pipeline to continue growing.
Now, it's worth pointing out that there are other, less high-tech solutions to this problem as well. CO2 can be captured by simply planting more trees, burying it in soil, and even adding alkaline substances to seawater, turning our oceans into giant carbon sinks. But these alone can't get us to the gigaton levels of carbon capturing that we have to achieve. So if the technology is there, and it's clearly a good thing, why are we not already installing these things all over the place? Well, there are several reasons, and chief among them is cost. It might be great for the planet, but carbon capture is expensive, and that's not much of an incentive. Then there's the issue of what to do with all the carbon that you've now got. Burying it underground is not always as easy as it sounds, and again, there's not much financial reward. A lot of places also don't have a regulatory structure for carbon projects, and the impact on local communities can be another challenge. That's why a lot of the carbon capture today is still used in a process called enhanced oil recovery. This is where CO2 is injected into an oil field to extract oil that's otherwise too difficult to remove. Yes, that's right, carbon that was captured from the air to stop climate change is being cycled back around to ultimately create more CO2. It might be far from ideal, but supporters of this method say it's at least helping the technology to scale up, and in time that CO2 can be used in better ways, including in construction.
The other options for utilization, there are quite a few in development, which is great. Some are in the building industry, actually. CO2 can be used to help cure the cement or the concrete. Some aggregate can be almost man-made using CO2. So you can create aggregate with captured CO2 and then use it in your concrete.
Right, so it's essential to cutting carbon emissions, and it can even help us build better. But can it really reverse global warming like some have suggested, or is that unrealistic?
I'd like us to get to 1.5. I'm crossing my fingers that we can get there. And it's going to be difficult. It's going to be very difficult to do that. So I think we should focus on a goal that is potentially achievable and put as much focus into that. If we do better, that's awesome.
It's easy to see why carbon capture has quickly become one of the biggest talking points when it comes to energy and the future of our planet. There's the potential here to make a huge step forward in our fight against climate change and get our carbon problem under control. But there's a lot of work to be done still, and when this new technology has finally matured, the construction sector will need to step up to the task, and fast. This video was made possible by Masterworks. You can learn more about that at the link below. There's also the chance to dive deeper on this and the other topics on our channel over on the World's Best Construction Podcast, available now wherever you get your podcasts. And as always, if you enjoyed this video and you want to learn more about where construction is headed, make sure you're subscribed to tomorrow's build.